Hello, dear friends. Today we will discuss RLC circuit, transient and steady state with DC supply. Very important concept and very important for the exam like NEET and JEE. So let us discuss some basic concept regarding this circuit. What is the behavior of this RLC circuit at steady state and at transient state when it is supplied with DC source. So basically transient condition or transient state means t equal to 0, means when initial condition, that is transient, when switch is closed, that is the condition of transient. Okay, when switch is closed, that is transient, and when switch is closed and we study circuit after a very long time, when switch is closed, that is called steady state. So, what are the behavior of inductor and capacitor in transient and steady state? We will first discuss this concept. After we will do this question. This is a question which is asked in NEET and also very important for JEE. So let us discuss first transient condition. So when t equal to 0, switch is closed, switch in the circuit is closed. So in the circuit, switch is here. So circuit may be of any type, may be of any complicated type, no problem. Just remember these two concepts. For transient condition, capacitor behaves like short circuit and inductor open circuit. Remember it. And in steady state means t tend to infinity, means after long time when switch is closed, at that time that condition capacitor behaves open circuit and inductor behaves like short circuit. So let us discuss this question. Question is asking, figure shows a circuit that contains three identical resistors with resistance R is equal to 9 ohm each, two identical inductors with inductance L equal to 2 millihenry each, and an ideal battery with EMF equal to 18 volt. The current I through the battery just after the switch is closed is. So in this question, it is asking the uh, current when just switch is closed. So this is the transient condition. So we apply this concept for a capacitor and inductor. So capacitor behaves like short circuit, inductor behave like open circuit. Now let us see circuit. Capacitor is short circuit and inductor is open circuit. So now this branch, the current will come here and totally pass through this branch because this is short circuit and this is open circuit. No current through inductor. So total current will pass through capacitor, and capacitor is short circuited here. And here resistance is parallel. So some current will pass through this resistance also. And here inductor will be open circuit. So no current in this branch. So in transient condition, only this resistance and this resistance is present in the circuit, and these resistance are in parallel. You can see here. So now we will find the equivalent resistance of this R and R. So R equivalent, that will be equal to equal resistance R and R. So it will be R by 2. So R is 9 by 2, that is 4.5 ampere. Now current I equal to current which is by current supplied by the battery, that is voltage E by R equivalent. So it will be 18 by 4.5. So it will be 4 ampere. So this is the answer. Correct answer is option B. Now let us discuss some another concept, that is steady state. Steady state condition. Now let us discuss apply steady state in the same circuit. So at steady state, capacitor open circuit and inductor short circuit. Okay. So inductor short circuit, current capacitor open circuit. So this branch is open, no current will pass through capacitor, and total current will pass through inductor because it is short circuit. This is a resistor with no capacitor and inductor, so no effect. So current will pass through this. And here inductor behaves like short circuit, so current will also pass through this circuit. So now this resistance and this resistance, these three resistance, all three are in parallel. So in this case, resistance equivalent of this circuit will be R by 3 because each resistance are identical. So it will be 9 by 3, that is 3 ampere. Now current drawn from battery, that is I equal to E by R equivalent. So it will be 18 by R equivalent is 3. So it becomes 6 ampere. So this is the current drawn from the battery at steady state condition, means a long time when switch is closed. So it may be in the question, the find the current when switch is closed. uh, Find the current after long time when switch is closed. So it will be 6 ampere in that case. So I hope this video will be helpful for you. Thanks for watching.